Hello and welcome back. I'm Matthew Lay. In today's lesson, we're going to talk about Ohm's Wheel. To date, we've talked about Ohm's Law and its triangle and Watt's Law and its triangle. Well, we can make a wheel of formulas based on those two triangles. We're going to look at that here today. So our objective is pretty simple. It's to understand the derivation of these formulas that comprise the Ohm's Wheel. So let's get into it. So just for review, Ohm's law, we have current is the dividend of voltage and resistance. So I equals E divided by R. Voltage is the product of current and resistance. So voltage equals I times R. And resistance is the dividend of voltage divided by current, or simply put, R equals E divided by I. So that's a review of our Ohm's law. Let's look at Watt's law here. So current is the dividend of active power divided by voltage. I'm kind of specific when I say active power. When we get into alternating current circuits, we're going to understand why I specifically denote active power. But for now, with DC, all power is active. We could just say it is power. So the current is the power divided by the voltage. Active power is the product of current multiplied by voltage. Simply put, P equals I times E. And voltage is the dividend of active power divided by current. So E equals P divided by I. Okay, so that's all review. We've talked about that in previous lessons. So let's talk about Ohm's wheel. Now you can see here in the upper right-hand corner that I have a wheel, and that's kind of where it gets its name. Kind of looks like a wagon wheel. And there's 12 total formulas that we have, 3 for each entity, whether it's power, current, resistance, or voltage. The Ohm's wheel contains all the possible formulas you would need to calculate power, current, resistance, or voltage with only 2 knowns. Okay, so we're going to see that when we're done comprising this wheel. The additional formulas are derived from the Ohm's law triangle and the Watt's law triangle. Okay, so here I'm showing both the triangles down in the lower right-hand section, and I've gone ahead and started to fill in our wheel based on our formulas that we just reviewed on the previous slides. But here, P equals I times E, I equals E divided by R, or P divided by E. E equals P divided by I, or it's I times R, and R equals E divided by I. And you can figure that out by covering up the letter and seeing the formulas in the triangles down there. But what we're going to do now is take those formulas and fill in these blank spots of other formulas. Because here, if we only knew voltage and resistance, we don't have a formula here yet to tell us how to calculate power, but we're going to do that now. Okay, so combining Ohm's law and Watt's law, we can build this Ohm's wheel, and we can use these formulas to derive the 6 remaining formulas and complete the wheel. Okay, so we're just going to work our way around clockwise, power, current, voltage, and resistance, and we're going to start with power here. And from the Watt's law triangle, we know that P equals E times I. Okay, so that's already up here in our little Ohm's wheel. And then Ohm's law, we know that E equals I times R. Well, we can use those two formulas together. The E in this first formula, we could substitute the I times R, and we can get P equals I times R. This I times R is the formula here from my E, and the I times R times the I can be simplified to P equals I squared R. Okay, so we went ahead and put that up here in my Ohm's wheel. So that's where an additional formula comes in. So if I knew current and resistance, I could figure out power. I don't have to know the voltage. Okay, what happens if I know voltage and resistance? Okay, so we're going to figure that one out here. So from the Watt's law triangle, again, we know that P equals I times E. And from the Ohm's law, now we know I equals E divided by R. So instead of substituting for the E, we are going to substitute for the I in this one. So in the Watt's law formula, we can substitute for I. So P equals E divided by R. That's this I we're substituting for, times the E, and that's the other term in that equation. And then we can simplify this. Remember, E is the same as E over 1. And in fractions, you multiply the numerators and your denominators. So multiplying the numerators, E times E is going to be E squared. Multiplying the denominators, R times 1 is just going to be R. So P equals E squared over R. Okay, so now we can place that there. So we have 3 different ways of calculating power. If we know current and voltage, we can calculate power. If we know current and resistance, we can calculate power. And if we know voltage and resistance, we can calculate power. And we're going to be able to do this for each one of these entities. Let's work our way over here to current. Now, we already have 2 of them because they come from our 2 triangles. I equals E divided by R, or I equals P divided by E. So E divided by R or P divided by E is what I is equal to. So we only have 1 more here to calculate, and let's see how we're going to do that. From the Ohm's wheel, we know that P equals I squared times R. So that's the one we just calculated here, okay, right here. And so that one, all we have to do is move it around and do one math formula, and we have our 3rd current formula here. So if we divide both sides by R, we're going to wind up on the left side with P divided by R, and on the right side, we're going to wind up with I squared. Now, we're trying to isolate I because we're trying to solve for I. And all we have to do now is we have I squared. So if we take the square root of both sides, that is going to yield I equals the square root of the fraction P divided by R. Okay? And so we can put that here, up here in the Ohm's wheel triangle as well. Not the Ohm's wheel triangle, the Ohm's wheel. Okay, let's move on to voltage here. Okay, so here for E, if I cover up the E, it's I times R. So there's my I times R. Or if I cover up the E here, it's P divided by I. So I already have 2 there. We only have to solve for a 3rd. Let's see how we can get that done. We know from the Ohm's law triangle that I equals E divided by R. And we know from the Watt's law triangle that I equals P divided by E. Okay, so I'm using these 2 right up here. Okay, so since they're both equations equal to I can set them equal to one another. Now this goes back to our math functions primer at the beginning of the semester. We can do cross multiplication. Cross multiplication means across the equal sign. So that would take the numerator of this equation and multiply it by the denominator of the other equation, and then take the denominator of the left side and multiply it times the numerator. That's what cross multiplication is. And when we do that, we're going to wind up with E times E on the left side and P times R on the right side. I kind of simplified that rather quickly on the slide here, but E times E is E squared equals P times R. So then all we have to do to isolate E, remember we're trying to solve for voltage, is take the square root of both sides again. So taking the square root of both sides yields E equals the square root of the product of P times R. Okay, so now we can put that in this equation, this wheel here, and we have our 3 equations for voltage. So if we know current and resistance, we can calculate voltage. If we know power and current, we know we can calculate voltage. And if we know power and resistance, we can calculate voltage. Okay, let's move on to our last component here, and that is resistance. From Ohm's law triangle, we know that R equals E divided by I. And from Watt's law, we know that I equals P divided by E. So now we can substitute the I in the Ohm's law equation with this P divided by E. So here R equals E divided by P divided by E. Okay, so we have a double multiplication, and we can do another math function on that. That's inverting the denominator and multiplying it times the numerator, which is what we're going to do here. So inverting and multiplying the right side yields R equals E over 1 times E over P. And if we simplify that, E times, remember, multiplication of fractions is multiplying the numerators and multiplying the denominators. Multiply E times E, you get E squared. Multiply 1 times P and you get P. So R equals E squared divided by P. And we fill that in here for resistance. Now we only have one more left. From Ohm's law triangle, we know R equals E divided by I. And from Watt's law triangle, we know that E equals P divided by I. So we're going to substitute this in for the numerator in this equation. So P divided by I is in the numerator, divided by I. We're going to do that same math function where we invert the denominator and then multiply it times the numerator. So inverting and multiplying the right side equals P over 1 times P over I times 1 over I. So multiplying the numerators results in just the P for a numerator, and for the denominator we're going to get I times I, which is I squared. So therefore R equals P divided by I squared. And that is our last component here, and this is our Ohm's wheel. And this is where the formulas on your Ohm's wheel sheet all came about. Now we won't have to actually derive those at all because we will have this available to us when we do worksheets, take quizzes, and tests. But I wanted just to explain where all those formulas came from, and hopefully you can have a greater understanding of how you can, given two, multiply, or given two components, be able to calculate any one of these, either power, current, resistance, or electricity. So just in quick review, the Ohm's wheel are just calculations that are derivations from Ohm's law triangle and the Watt's law triangle. This concludes our presentation on the Ohm's wheel. I hope that was helpful, and we'll see you in the next video.